So continuing on, here's our next one. I know we were just doing it, but here we've got the polar rectangular form. We're going to go to polar, complex polar. Um, two of these, and then we're going to do two backwards, which are actually pretty straightforward, although the last one can be a little tricksy. So here, let's go ahead and plot this. -4, and then +4i. A presumably straight line. All right, so our radius, or the modulus, if we want to use the fancy term, big square root of -4 squared plus 4 squared, which is 2 times 4 squared. The 16 is square rootable. The 2 is not, so it's 4 square root of 2. And hopefully this is familiar where it's like same sides are equal, like the two legs are equal. So this is a 45-degree reference angle, which makes this 135, which is 3 pi over 4. If we do inverse tangent will give us -45. And then we have to know to add pi so that we get the thing in quadrant 2 instead of quadrant 4. So z is 4 square root 2 cis 3 pi over 4, because I'm feeling lazy. All right, another one with a square root of 3. Is it going to be the 30 or the 60? I know I'm just ruining things, aren't I? All right, so -2 square root 3, -2i. All right, so one side's a number, the other side is the number times the square root of 3. This is a 30, 60, 90. Alongside here, so this is a 30-degree reference angle. The whole thing is 210, which is 7 pi over 6. Inverse tangent is going to give you positive 30 degrees. So you still have to plot the point to know where it is, to know what kind of angle you should be getting. So when you do inverse tangent, if it's in the wrong quadrant, you add pi. That'll put it in the right quadrant. All right. So the radius so -2 square root 3 squared plus -2 squared. So this is 4 times 3 plus 4. 12 plus 4 is 16. So our radius is 4. So z is 4 cis 7 pi over 6. So they're deliberately picking numbers that are unit circle angles. Like they're picking the legs of stuff that's the angle is on the unit circle. The points where we're graphing these are not, though. Like this is a radius of 4, so it's not on the radius 1 circle, but the 7 pi over 6 is definitely on that circle. All right, now we're given the polar notation and asked to go back. This is very much, look it up on the unit circle, write down the fractions, multiply by 12, done. So pi over 6 is long side, short side. So square root of 3 over 2 and 1/2. So our z is the same as 12 times square root of 3 over 2 plus I times 1/2. And then we just need to distribute the 12 through. So 12 times square root of 3 over 2 is 6 square root of 3 plus 12 times 1/2 is 6 with an I, and that's it. Can't combine those. Just literally just crunch the numbers. Okay. So this last one here is a little bit weird. They've given us the radius and they've given us the tangent of theta. So I could use this to calculate theta, and then I can just do the cosine of theta and the sine of theta. But when they give us the tangent like this, well, one, it's positive, so we would assume that theta is in quadrant 1. So it's 12 and 5, and then our unknown c. And then we have our r, which may or may not be the same as c. So we still need to use our same r cosine theta plus I sine theta. But because they gave us a nice fraction, we can Pythagorean theorem for the third side. And in this case, it turns out it's our 5 and our 12 again. 144 and 25 is 169, which is 13, which is our radius. I'd say coincidence, but I think it's actually deliberate. I think it would have been better actually if they gave us a radius that wasn't the hypotenuse length. So you could see that telling you the tangent isn't setting the size of the triangle. This triangle could have been 10 times as big, could have been 8 times as small. All the tangent theta does is sets up the proportion of the two sides. All right, so using our form, I've got 13 for my radius. And then the cosine of theta, here's our theta. Cosine would be 12 over 13 plus I times the sine of theta is 5 over 13. So when we distribute the 13 through, like I said, if it was a different radius, like then you'd actually see these numbers would change. Here, though, the 13s are just going to cancel. So we just get 12 plus 5i. So it looks like, oh, I could just ignore r and just do the tangent. No. It is only because this radius happens to be the length of the hypotenuse of the triangle set up by tangent. Pure coincidence. Alternatively, if you just found the angle and then did the cosine of theta, the sine of theta times 13, you'd probably get something like 12.000001 and 4.999999. But, close enough. All right. So the next video is going to do products and quotients.